Hey, hi, welcome to the video. In this video we will discuss about the maximum power that a wind turbine can capture, that is the coefficient of power. Now it's a long procedure, so what we will do is we will break the videos into n number of parts and finally reach our objective. So let's start. What is a wind turbine? Now, wind turbine basically is a device which converts the kinetic energy of the wind into the mechanical energy and then into electrical energy. So just imagine that this black ellipse is a side view of wind turbine rotor plane, and this orange line is the velocity vector of the wind. Now, wind is a velocity, that means it is random in nature and it is a vector. It has a magnitude and it has a direction. So wind can come from any direction. It could come from this direction, it could come from this direction, it could come from this direction, it could come from any direction, and it could be having any magnitude. So what we want is to expose the maximum amount of rotor area to the wind. How is it possible? It is only possible if the velocity vector of the wind and the rotor plane are perpendicular to each other. For that, what we do is we make a yaw control. So what is yaw control? Yaw control is a mechanism by virtue of which the rotor plane of the wind turbine is perpendicular to that of the wind velocity vector. So yaw control is somewhere here. So the purpose of the yaw control is only to face the rotor plane perpendicular into the wind turbine so that it can expose the maximum amount of area of the rotor plane. Alright, so now just imagine this orange line is the velocity vector, and because of the yaw control it is perpendicular to the rotor plane. Now what we are interested is the maximum amount of power that is available in this wind. Now what is power? When we say power, power is nothing but energy per unit time. What is energy? Energy is nothing but the kinetic energy available in the wind. What is the kinetic energy which is available in the wind? It is nothing but mass times the velocity of the wind squared. Now we can even say that power is equal to force times the velocity. Force times the velocity of the wind. So what we are really interested is to know the power which is available by this because of this wind on this rotor plane. Now what is force? Force is nothing but, if we break it down, it is equal to the density, or you can say half times the density of the wind, which is generally around 2.225. It depends on the altitude. So let's consider it to be 1.225 kilograms per meter cube. So it is half times the density times the area. What is the area? Area is nothing but the area of the rotor plane. It is nothing but a circular disc, so it is pi r square. So let's down pi times r times squared times the magnitude of the wind, which is V squared. Right, so here we have, now we know that this is the force. Now this is the force of the wind. What we are interested is the maximum available power, which is nothing but force into velocity. So now power will become velocity cubed. So this is the maximum power which is available in the rotor plane because of the wind, but that can't be the power which is extracted by the wind. Now the power which is extracted by the wind turbine is the function of tip speed ratio, which we will come later in the video. But for now, we know that the maximum power which is available in the rotor plane is half times the density into the area times the velocity cube. So now in the next video, what we will do is we will analyze the angles and the twists and chords and how do we design the wind turbine according to the location. Now when we see coefficient of power, coefficient of power is nothing but the maximum power which is available to the generated power by the wind turbine. Now just imagine you have this vector. This is the wind velocity vector. It is perpendicular to the rotor plane. Now these blades are rotating at certain angular velocity omega. So if we draw another vector, the velocity vector of the elements, or you can just consider the tip of the blade. Now if you develop it, it would look something like this. Okay, so now this line is representing the wind, the element linear velocity, the linear velocity of the element along this perimeter. We have developed it right now. So naturally the linear velocity at which the element, or you can say the molecule, which is farthest from the origin, from the axis of rotation, is nothing but radius times omega, isn't it? So let's write here. Now this vector is r omega and this vector is wind velocity, right? So this vector has this direction and this vector has this direction. Okay, right. Now just imagine what's going to happen if you imagine that there is some wind which is blowing at certain velocity. So this guy here is the wind velocity. This is the wind velocity, and this vector here is the tangential velocity, or you can say the linear velocity of the element. What would it be? It is nothing but radius times omega, isn't it? So we write here this is r times omega. Now what do you think would be the actual velocity that has been experienced by the element which is on the tip of this blade? It has to be the summation of these two vectors. So the magnitude that it would experience has to be the summation of wind velocity vector and tip velocity. It has to be the summation of wind vector and the tip, right, and the tip linear velocity. So it would be this. Now this we can call it as the relative velocity. This is the velocity which has been experienced by the molecule which is on the tip of the plate. This is called as, now what is tip speed ratio? Tip speed ratio is a very important tip speed ratio is is extremely important. What is tip speed ratio? Tip speed ratio is nothing but the ratio of the velocity at which this tip is traveling at to the velocity of the wind. So it is nothing but r times omega divided by the velocity of wind. Now let us see this. Now let's copy this and paste it over there. If you can see this diagram, you can see now this is exactly the same diagram. Now what we do is we will invert this so that you get an idea.